Think about the year you turned 7. Try to pull up a single complete day. Not a flash, not a fragment, an entire day from morning to night. You can't do it. Nobody can. And most people assume this is just how memory works, that childhood fades the way old photographs fade, slowly, evenly, from the edges inward. But that's not what's happening inside your skull. Your brain didn't lose those years. There's strong evidence it deleted them on purpose, using a mechanism that scientists have only recently started to understand. And the same system that erased your childhood is still running right now, quietly deciding what you get to keep and what disappears forever without ever asking your permission. This isn't a metaphor. This is wiring. Let's start with the part that should already feel strange. You weren't unconscious as a toddler. You were aware, responsive, learning language, forming attachments, reacting to the world with real emotion. A 2-year-old who falls and scrapes their knee cries real tears and feels real pain. That experience was processed by a functioning brain in real time. So where did it go? For decades, the dominant explanation was structural. The hippocampus, the brain region responsible for converting short-term experience into long-term memory, simply isn't finished developing in early childhood. This is true. The dentate gyrus, a critical subregion involved in distinguishing one memory from another, doesn't fully mature until somewhere between ages 2 and 4. Before that point, the argument goes, the hardware for permanent storage isn't ready. But this explanation has a problem. It doesn't explain why children can clearly remember things for days or weeks at a time, only to lose them completely by adulthood. If the hippocampus were simply offline, those memories should never form in the first place. Instead, they form, they persist for a while, and then they vanish. That's not a storage failure. That's something closer to active removal. In 2014, 2 neuroscientists in Toronto ran an experiment that changed how the field understood this gap. Sheena Jocelyn and Paul Franklin at the Hospital for Sick Children were studying neurogenesis, the process by which the brain generates brand new neurons throughout early life. Neurogenesis is essential. It's how your brain builds the circuitry you'll use for the rest of your life. But Jocelyn and Franklin suspected it came with a hidden cost. Here's the logic. Every time a new neuron gets wired into an existing circuit, it has to insert itself into a network that's already carrying information. Imagine trying to add a new section to a building while people are still living inside it. Something has to move. Something has to be reorganized. The researchers hypothesized that new neurons weren't just adding capacity, they were displacing the connections that already existed, the ones holding old memories in place. They tested this directly in mice. When they artificially boosted neurogenesis in adult mice, those mice started forgetting things they had clearly learned before. When they slowed neurogenesis down in infant mice, those infant mice held on to memories for much longer than expected. The results, published in the journal Science, pointed to something deeply counterintuitive. The same explosion of new brain cells that builds your mind in early life is also what tears down the memories stored inside it. Your brain wasn't failing to save your childhood. It was overwriting it on purpose as a side effect of growing. This is called infantile amnesia, and Freud was the first person to formally describe it back in 1905, though he had the mechanism completely wrong. He thought repression was driven by trauma and unconscious conflict, an idea that shaped a century of psychology and an enormous amount of pop culture. But the actual biology turned out to be far less dramatic and far more universal. You didn't repress your early childhood because of psychological conflict. You lost it because your brain was under construction, and construction required demolition. But neurogenesis is only the first delete mechanism. There's a second one, and this one runs your entire life, not just early childhood. It's called synaptic pruning, and it works on a principle neuroscientists summarize with a brutal little phrase: use it or lose it. Your brain doesn't have unlimited room to keep every connection you've ever formed, so it runs a constant background process of evaluation, strengthening the neural pathways you use frequently and weakening, then eventually eliminating the ones you don't. A memory that never gets revisited, never gets talked about, never gets triggered by a smell or a song or a place, sits on a pathway that's slowly being marked for deletion. This is happening to you right now, in real time, as you read this.
Somewhere in your brain, a memory
you haven't accessed in years is one unused synapse weaker than it was yesterday. Researchers have shown that synaptic pruning is most aggressive during two specific windows: early childhood and adolescence. During adolescence alone, the brain eliminates roughly half of the synaptic connections present in childhood. Half. Not because something went wrong, but because this is how an efficient brain operates. It keeps what's useful and discards what isn't, and it makes that judgment without consulting the part of you that might have wanted to keep a particular memory around. Here's where it gets genuinely unsettling. This pruning process doesn't just delete neutral information, like what you had for breakfast on a random Tuesday. It deletes things indiscriminately, including memories tied to identity, relationships, and formative experience. Researchers studying autobiographical memory have found that most adults, when asked to recall their earliest memories, can only reach back to somewhere between age 3 and 4 on average. And even those memories are often partial, sensory fragments, rather than full coherent scenes. A flash of a kitchen, the sound of a specific door, nothing connected, nothing complete. And there's a darker twist buried in this research. The phenomenon isn't limited to early childhood. Adults experience a smaller, less discussed version of the same thing, called childhood amnesia's long tail, a steady erosion of memories from ages 5 through 7 that continues well into adulthood. A landmark study by psychologist Patricia Bauer found that even memories formed at age 7, well past the supposed end of infantile amnesia, show significant decay by the time a person reaches their 20s. The delete mechanism doesn't have a hard stop date. It has a fading intensity, like a dimmer switch instead of an off switch. So if your brain is constantly pruning unused memories, why do some moments survive forever while entire years disappear? The answer involves a structure most people have never heard of: the amygdala. The amygdala is your brain's emotional intensity detector. When something happens that triggers a strong emotional response, fear, joy, danger, humiliation, the amygdala essentially flags that moment and tells the hippocampus to prioritize it. This is why you can probably remember exactly where you were during a single terrifying or humiliating moment from 15 years ago, while 10,000 ordinary Tuesdays from that same period are completely gone. Your brain isn't archiving your life chronologically, it's archiving by emotional significance, and everything that doesn't meet the threshold gets quietly recycled. This explains something most people have felt but never been able to articulate. The years that vanish most completely tend to be the calm ones, the unremarkable stretches with no major emotional spikes. Meanwhile, a single afternoon, one conversation, one specific look on someone's face can survive in perfect detail for decades. Your memory isn't a record of your life. It's a record of what your amygdala decided mattered, filtered through a pruning system that's actively destroying everything else. Now here's the part that should genuinely concern you. This isn't only happening to memories from childhood. It's happening to memories from last year, from last month. The synaptic connections holding a memory from 6 months ago are, right now, in active competition with every other memory you formed since. If you don't revisit it, talk about it, write about it, or get reminded of it by some external cue, its physical foundation in your brain is being weakened on a daily basis. Most of what you're living through right now will not survive the next decade, not because your brain is broken, but because it's working exactly as designed. Researchers have found one of the only reliable countermeasures, and it isn't repetition in the way most people assume. Simply replaying a memory in your head over and over doesn't necessarily protect it, because every time you recall something, you're not pulling up a perfect original recording, you're reconstructing it. And that reconstruction is influenced by your current mood, your current beliefs, and everything that's happened since. This is called reconsolidation, and it means memory isn't stored like a file in a cabinet. It's rebuilt from scratch every single time you access it, which means every memory you have has been subtly rewritten an unknown number of times since the original event occurred. This is why two siblings can argue for hours about what really happened during a childhood event, both absolutely certain of details that flatly contradict each other. They're not lying. Their brains have independently reconstructed the same event so many times, shaped by years of separate emotional context, that the memories have diverged into two different stories built from one shared origin. So what does this actually mean for you, sitting here right now? It means the version of your childhood you carry around isn't a recording, it's a heavily edited reconstruction, built from emotionally significant insignificant fragments, stitched together by neurogenesis-driven overwriting and decades of pruning, then reshaped slightly every time you've ever told the story to someone else. The you of age 5 formed real memories. They existed, and your brain, doing exactly what brains are built to do, deleted almost all of them to make room for what came next. This isn't a flaw in the system, it's the system working correctly. A brain that kept every memory of every day at full resolution would drown in irrelevant data, unable to function, unable to prioritize, unable to learn efficiently from experience. The forgetting isn't a bug sitting alongside the remembering. The forgetting is what makes the remembering possible at all. Right now, somewhere in your skull, a memory from this exact year is competing for survival against thousands of others, and most of them are losing. Not because they didn't matter to you in the moment, because nothing flagged them as important enough to keep. And the system that decides what survives was never built to ask you first. You won't notice it happening. You never have. That's the part nobody tells you. The delete button doesn't make a sound when it's pressed.